Hello everyone. In this part, we will conduct a small, quick data analysis where we are going to demonstrate the skills that you are going to learn in this series and any upcoming series, just to get a sense of the overall process we are going to go through. The data we are going to work on will be obtained from a hypothetical company called lenders.com, which is an online company that offers consumer loans. So let's get started. Here we have the process we are going to go through, starting with the data collection. Uh, in this phase, we simply collect the data from one source or diverse sources, and then work on it. In the next step, we clean the data to make sure that it's up to standard. And the next step, we explore the different variables in our data set to study their pattern, their distribution, their different characteristics. And finally, we model the data and interpret the results to aid us in our decision-making process. So, starting with the data collection, as I mentioned, normally the data is collected from different sources and then aggregated into one or multiple data sets on which the analysis will be conducted. But since this is a hypothetical demonstration with a hypothetical company, the data set is already in our hands in an Excel sheet. So here, as we can see, the data consists of 12 columns total with 3,000 rows. It's called loan approval data. Let's go over the columns we have. First, the applicant name. This one is clear, right? This is the name of the applicant. In the second column, we have two information, the gender and whether the applicant is married or not. So it's, for example, male in this case, and no, the applicant is not married. The third column is children, the number of children the applicant has. Third, education level can be, for example, associate, master's, bachelor's, PhD, etc., etc. The property area the applicant is living in, whether it's urban, semi-urban, or rural. We have the purpose column, which is basically the purpose of the loan. Is it for business funding, medical, debt consolidation, travel, etc., etc. In this column, the loan amount is simply the amount requested by the applicant from lenders.com, the annual income of the applicant, the debt ratio, which is simply the loan amount divided by the annual income. Credit greater than 2 years is just a flag that tells us whether the credit line of the applicant has existed for more than 2 years or not. Yes, if it was, no, if it wasn't. And then we have the credit score of the applicant. For example, 667 for this one, 727 for this one, and so on and so forth. And finally, the default flag or the default column, which basically tells us if whether the applicant has defaulted on any of the loan payments in the future or not. All right. So basically, that's all past data that exists in our database or in our system, which we are going to work on in this case. Second, here we have the data cleaning phase of the project. In this case, we will investigate the existence of any irrelevant columns. These are simply columns that will not be of much value in our analysis, so we are better off without them. And then we'll see if there are any empty cells or null values. In this case, we either eliminate them or we fill them up according to a certain criteria. And then we have data sets with the wrong format. For example, some date column with a wrong format that needs to be corrected. Wrong data points. These are points that are out of a specified allowed range for values. We have the outliers, which are simply extreme values, which can affect the analysis negatively. So we are better off without them as well. Duplicate rows, this one is self-explanatory. These are simply rows that are duplicated. So in this case, we can simply eliminate them. Now let's move on to this Excel sheet. So here is a sample of the full dataset in which we are going to do our data cleaning. Keeping in mind that the cells or the columns colored in red are simply uh, cells with issues in them that needs to be corrected. So let's look at them one after the other. Starting with this column, as we can see, both or two types of information are aggregated in the same column. So what we can do in this case is to separate each feature or variable into a separate column, right? So what we can do is to insert a new column, right? And then from the data tab, we go to text to columns. The columns are delimited. Next, we choose other. The separator, as we can see, is a slash, right? So we click next. But before that, we should highlight the whole column. Text to columns, next, as we can see here, next, and finish. The data, there we go. Now we have both columns in separate columns, or both variables in separate columns. Okay, next, as we can see, this row is highlighted in red, and it's clearly a duplicate of the first row, number 3. So what we can do is to simply delete it. But first, just make sure that the values are the same across all the values, right? So the applicant name is Alex, gender is male, married, for masters, urban, medical, the same annual income, same loan amount, debt ratio. So everything is identical, and therefore this is a duplicate row, which we can delete. Keep in mind that in this tutorial or part, we are not teaching anything. We are just demonstrating what you are going to do in the future using different tools and techniques. But for now, just stay with me on what to expect. Let's change the color to normal back. All right. Now, married, children, nothing is wrong with them. Education level, property area, purpose, loan amount, all good. Annual income, as we can see, this value is in the wrong format, right? There's a dollar sign here, and there are some decimal points as opposed to the remaining data points here. So what we can do is simply take the format of this one, okay, and apply it to this one. Now we have 32,000 with the same format as the others. Debt ratio, the values here seems good. Credit greater than 2 years seems good as well. Here, as we can see, we have two problems in this column. The first one is that this one contains a null value or an empty cell. This could uh, pose diverse effects on our analysis, so we must deal with it, right? The other issue here is a wrong value, right? 7,070 is clearly out of the acceptable range for a credit score value, right? So both of these need to be corrected. Let's start with this one. This one is clearly a typo or some other issue, right? It's clearly 707. So what we can do is to delete the trailing zero, or we simply delete the whole row that contains the wrong value. But in this case, we are better off simply correcting it. The other issue here, again, is that we have an empty value, so we either can eliminate the whole row, or we can fill it up uh, according to some technique, right? In this case, what we can do is to simply take the average of these values and give it to the cell. Or we can take a look at applicants with similar characteristics and apply the same credit score for this one. All right. So in this case, let's simply take the average, right? Average of all of these is 704.5. We round it to 705. All right, let's delete it and simply say 705. All right, and we are done. Let's correct the format of this one and the format of this one, and we are done with the data cleaning for this sample of the whole dataset. Keeping in mind again that in the future the datasets will be much bigger and we won't be able to manually investigate and correct the different issues. What we are going to do is to use different programming languages with different libraries and tools to investigate, extract the different issues, and automatically correct them using certain programs we are going to write. All right. Okay, back to our demonstration. We are done with the data cleaning process. Let's go to the data exploration process. Right, and it includes visual and non-visual components. This phase contains visual and non-visual components. In this phase, we are going to study the type of each variable, whether it's numerical or categorical, for example. We're going to study different characteristics of the variables, that is the descriptive statistics like the mean, mode, a median, variance, standard deviation, etc. And study the shape or the pattern or the distribution of the different variables to see if the values in a certain variable are close to each other or spread out, whether there are extreme or outliers in the different variables, whether the values follow a normal distribution or uniform distribution or any other type of distribution for that matter. Fourth, we are going to investigate the existence of any trends in our data. And fifth, we will study the relationship between the different variables. Is it a positive relationship or negative relationship? We're going to talk about the different types later on. Starting with the studying of the variable type, right? So here we have few sample rows, sample columns. So for example, for children, the values there are like 0, 1, 4, 5, 2, etc. So clearly this one is a numerical, right? Second, for education level, we have classes or categories like associate, masters, or PhD. So this one is categorical. Third, we have the property area, which can be urban, semi-urban, or rural. So this one is definitely categorical as well. And lastly, we have the annual income, which is clearly numerical, like 23,000, 9,000, 8,000. So this one is numerical as well. All right, next we will study the variable shape and characteristics. In this case, we will start with the column called gender, right? And we can see the distribution of values. In this case, we have 81.4% of the observations as males, right? And the remaining 18.6% are females. And this become apparent from this tooltip that we clicked on in the program we worked with. So this one is an example. A second example is the credit score. In this case, we will use a graph called the histogram in order to combine the different observations into different bins and then figure out the frequency of the observations belonging to each bin, right? In this case, for example, in this bin right here, with the values ranging from 675 to 700, we have 156 observations. So this bin has the highest frequency of data points. All right, and the same thing applies for the remaining bins, keeping in mind that all of the bins are of the same size, but with different ranges. Again, we're going to talk about this type of graph in more depth later on. But for now, we just simply use it to understand the distribution of the credit score variable or column. Next, we're going to study some descriptive statistics of the same variable, which is the credit score. In this case, the mean or the average value was 715. The standard deviation was 39. The minimum value was 627, and the maximum value was 822. All right. So as you can see, there are so many ways to study the different or to explore the different variables we had to better make sense of them. And finally, we have or we study the relationship between certain variables. In this case, we want to see the correlation or the relationship between the annual income and the credit score. Keep in mind that the correlation value, right, ranges from -1 to 1. The closer we get to 1 or to -1, the stronger is the relationship. If the sign is positive, it means that as one variable increases, the other tends to increase as well. If the sign was negative, it means that there is a negative relationship, and therefore, as one variable increases, the other tends to decrease. So it's a negative relationship. So in this case, we'll pay attention to the sign that comes before the number, right? As well as the value that comes after it. Is close to 1 or -1. So between annual income and credit score, the correlation value is positive 0.8, which means that there is a positive relationship. As the annual income increases, credit score tends to increase as well, right? The value is 0.8. This is a relatively high value, which means that the strength of the relationship is high, right? Here is the simply visualization of how the relationship looks like. Between children and loan amount, as we can see, we have negative 0.7, meaning as the number of children the applicant has increases, the loan amount requested by the applicant tends to decrease, right? The value here is 0.7, which also is relatively high, right? So that suggests that there is a strong relationship between the number of children and the loan amount. And here again, we have a visualization of the relationship. As one increases, the other decreases, all right? So that was it for the data exploration phase. We have done with the collection, we have done with the cleaning, we are done with the exploration. Now we move on to the last joint step of model creation and interpretation. Normally these two steps come separately, but in this case we simply combine them for clarity. The models we are going to create are first a model that predicts whether an applicant will default or not. So simply, we want to train a machine learning model, all right, that can accept some characteristics value of the applicant, and then produce a judgment or a class, which is whether the applicant will default in the future on the payment or not. All right, so simply the model will predict whether the current applicant will default on any of the loan payments in the future or not. All right, this is just or the deployment of this model is a precautionary uh, uh, move just to save the company money and to make its work more efficient. The second model is a model that puts past applicants into groups. So we have in our database so many past applicants. We want to make use of this data. How? By assigning or by creating a model that can assign the past applicants into different groups according to their characteristics. After that, we will target the past customers in each group with a customized marketing campaign according to their different characteristics. Okay. Now, here in this case, when it comes to machine learning, the columns of a table are called the features, whereas the target column is called the target. Okay, it's basically the column that contains the classes the model will predict, right? The model we will create will simply predict whether the applicant will default or not. So it's a yes or no. So this is the target variable, and all of the remaining columns or variables are the features the model will use to produce the prediction. All right, let's see a scenario that illustrates this idea. So in this case, Alex is an applicant that went online to lendus.com and provided his information, including the annual income, the loan amount, and the number of children he has. All right. all of these data were fed into an already trained machine learning model, right, or system, all right, and that model, depending on the input information of Alex, spit out or produce a class. This class was yes. So it's either yes or no. Yes means that it's expected that this applicant will default in the future, and no means that this applicant is expected not to default in the future, and therefore he can be trusted with the provided loan, right? In this case, the judgment or the classification of our model was that this person or Alex will actually default in the future, and therefore we should be worry of him, right? If the company solely depend on the decision of the machine learning model, trained machine learning, then they are going to simply send a rejection letter to Alex informing him that his application was simply rejected, right? It's rejected. On the other hand, we have Jessica who went through the same process. She went online to lenders.com, filled some information, annual income, loan amount, children, property area, and all of the remaining values we've talked about in the previous slides, right? And then, depending on those values, I'm sorry, those values were fed into the trained machine learning model, and the model produced the classification or predicted that Jessica will not actually default in the future on her loan. Okay. Again, if the company relies on the judgment of the model, then they are going to send an approval letter of Jessica informing her that her application was simply approved. All right. Now you might be wondering, how would the model know whether a specific person will default in the future or not? This is basically done through training the machine learning model on some past data we have on our database, right? So this is some data. We feed it into a machine learning model. The model starts investigating the values of the different variables, studies the relationship of the different variables, and the eventual result, right? So it basically forms associations and relationships and many other considerations in order to study or make a reliable judgment in regard to the class of a specific observation, right? Okay, the second model is a clustering model or a clustering machine learning model, which is used to group the different applicants into different, well, groups based on their credit score and annual income, right? So we gave our model the different observations, specifically the credit score and annual income values, and our model has produced three different groups, right? We have green, red, and blue. All right, now depending on the groups produced by our model, we will start sending different marketing campaigns to the people inside each group. So for example, in this blue group, we can see that the annual incomes of these people is relatively low, right? And the credit score of those people is also relatively low. So we can send a small loan offers to the people in this group. On the other hand, in the red group, we can see that the annual income of these people is relatively low. However, their credit score is relatively high, meaning that these people are reliable and they are expected to not default in their loans and to pay the loan on time, right? And therefore, we can offer them higher amounts of loans because they are expected to pay back, right? So as you can see, we are treating the people in the different groups differently based on that clustering. And the same thing applies for this one. Okay, uh, so that was it in this simple demonstration. We did some data collection, some data cleaning, some data exploration, and finally some data modeling and interpretation. If you liked what you saw, if you felt intrigued by the different techniques we have briefly applied in this demonstration, then follow along and continue with this series where we are going to establish a good foundation on which we are going to build uh, on your knowledge in this field. So thank you for watching, and I will see you in the next tutorial.